So let's continue the part 2 of work energy power. And in work energy power part 2, we will be starting with vertical circular motion. So yeah, the first let's solve in types of questions so that we get a feel on this vertical circular motion thing. So let's have a question. Let's say this point is fixed and we have an string which is connected to a ball. Okay, it is initially in this position and it has mass m. So we are gonna rotate this string with some velocity, and you can see when it reaches here, it's gonna be v velocity is gonna be equal to 0. Right? Find the minimum velocity of a so that the particle reaches the point b. So as you can see here, the velocity is gonna be 0. By work energy theorem itself, you can basically solve this problem. The two forces which are acting in this particle are tension force and the gravitational force for sure, right? So minus mgl, so l is basically this length, right? So this is also l because it's a circular motion. Wherever you go, this length is l, this length is l, so everything is going to be l. Okay, minus mgl plus tension force, which is always perpendicular to the displacement, and in this case particularly here it's gonna be equal to 0. Okay, so equal to final, as we all know, vb becomes 0, so final kinetic energy is 0, and 1 by 2 mva square. So va is the velocity at this point. So with this, when you manipulate it, you get va is equal to root under 2gl as the answer. This is a good result. If some questions comes like this, you can actually answer in like simply root 2gl if the same case comes. So this is also a result. Maybe you can remember it. It will be useful for some questions. And we also need to find the maximum deflection of the string. Let's say a particle is here, okay, and it is released from this point, and it goes like this, right? Like an motion in SHM. So we need to find the maximum deflection, which is theta maximum. Fine. So yeah, simple case. So at the maximum deflection, f is equal to 0, because further that it won't move. That's why we call it as maximum deflection. So it's gonna change the direction. In that case, final velocity will be equal to 0. So initial velocity is given, which is a velocity at point A is equal to root gl. Okay, and we also know that this length is l, which means this is l cos theta. Okay, so when we draw a particular line here, we can observe that this vertical height displacement is simply l cos theta. Okay, and this length is l. So basically we need the vertical displacement is basically l minus l cos theta, right? So yeah, this will be the height, vertical displacement. So with that, you can apply in the formula of work done by the gravity, which is minus mg l minus l cos theta plus 0 is equal to 0 minus 1 by 2 mgl. Okay, gl is already given here, so this is root under gl. Okay, so yeah, when you square that, the square get cancelled and it will come like 1 by 2 mgl. Fine. So m will get cancelled, g will get cancelled, and when we take L common outside, L will cancel, and then cos theta will be equal to 1 by 2 and theta will be equal to 60 degree, which means the maximum deflection will be 60 degree when the particle is given with the velocity root under GL. It can go up to this point where theta is equal to 60 degree. Fine. Find the minimum velocity at the point A so that the vertical circular motion completes. So basically what they are asking is, what is the minimum velocity so that it goes like this and it completes the vertical circular motion. Okay, so let us solve this question. So basically, at a point it's gonna have these forces mg for sure, mg, and towards the string which is t, and we have two components of mg. Okay, now what can we go to NLM concept where when we studied about circular motion, we can write this equation, right? So t minus mg cos theta will be basically equal to mv square by r, centripetal force, if you remember. And then we can write the tension is going to be mg cos theta plus mv square by r. Okay, when velocity decreases, theta will definitely increase. Okay, these are the relations which you can find in this formula. Fine. After that, if you observe, minimum tension will be at the highest point. Okay, at this point actually it will have minimum tension, and basically it won't be equal to 0, because when it is equal to 0 it won't be in the, it means the rope is actually disconnected. In that case it won't actually perform a circular motion, instead it will just collapse the circular motion. So it is not equal to 0, but I can tell that it's gonna be nearly tends to 0. Okay, so however tension at C is gonna be equal to or tends to 0 plus mg. Okay, what is mg? At this point tension will be acting here, and mg also will be acting in the same direction, so tension plus mg is equal to mv square by r. Okay, so vc will be, you will be getting as root gr, root gr. Fine. So at this point you will be having velocity root gr. Fine. So at c we have found that root gr. Then what is the velocity at A? Again, apply work energy theorem. Simply work done by gravity, which is L. The vertical displacement is 2L. So work done by the gravity is plus mg 2L plus 0. Okay, normal force 0. So retention force, it's always perpendicular, so it's going to be 0. And yeah, what about this? These two equations, we have found that vc square for sure. We need to find va, so I think this is not a big deal. So also when you solve a lot of questions, you will also observe a pattern. I think this much calculation is not required basically to find these values. So you can observe that. So this is basically summary. First understand that if here 5gr should be given, 5gr should be given to complete this to here. Okay, to complete a vertical thing you should give 5gr velocity at the beginning itself. So when it goes goes motions like this, you will get vb, which is equal to root under 3gr. Okay, and then it reaches here with the velocity root gr. Okay, whenever they can give some questions like va is equal to let's say 7gr, we will be seeing after this. So you will be asked like what will be the velocity when it crosses b. So simply just subtract 2 from that, you will get 5gr. That will be the velocity when it crosses vb. Yeah, we'll see, don't worry. If you don't understand, it's perfectly fine. Yeah. So yeah, let's do a motion analysis. Okay, what we have learned till now is simply the starting. So basically what we have learned is to complete the motion till the half thing, you basically need to supply root 2 gl. Do you agree with me? So let's go back. Yeah. So what will happen when you supply less than root 2 gl? Of course it will come to zero. The velocity will be coming to zero before the point b. This is the point b. Okay, it will be coming to zero before the point b itself. So what if velocity is equal to root under 2 gr? So at vb correctly, it will be velocity will be equal to 0. What if the velocity at a is given as root under 5gr? So when it given 5gr, we have studied before that it can complete it, and vc will be gr, right? So it's gr. So tension at c will be equal to 0. Okay, so yeah, same condition somewhere between b and c. So it will be somewhere between b and c when you give the force in between root gr, root 2 gr and root 5 gr. And when you give definitely above root 5 gr, it will definitely complete the circular motion, right? Yeah, so in this question, that's what I've said. We need to find velocity at a, velocity at b, velocity at c, velocity at d. When from a to b we need to apply work energy theorem, from a to c we need to apply work energy theorem. That's the one way of getting it. I hope you must have got an understanding of how to do these kind of things. But another shortcut way is you just need to minus 2 from that. So basically 7 minus 2, you get 5gr. So when it reaches here, so you will get root 5gr, and minus 2 from this, which is root 3gr. I hope you understand this simple shortcut. This will be used in a lot of things, right? I mean, to make the question actually simpler. So again, the velocity at a will be 6, let's say. This will be 2, this will be 4. So 4 minus 2 is 2, 2gr, root under 2gr. If they asked you to find the tension at a, what will you do? So basically apply the normal NLM thing. So here tension force will be acting, and then here mg force will be acting. So Ta minus mg will be equal to mv square by r. We know that v here, so just square it and you will get this equation. Fine, I hope you understand this. Next, thing is, if they ask to find the tension here, it's also simple, right? So basically you will have mg acting on this side and tension also acting on this side, okay, which makes you tc plus mg is equal to mvc square by r. If you don't understand this, please first study circular motion and then come to this video. That will be really helpful. Okay, this is an interesting question and this is an easy question as well. So there is a ball kind of thing which is dropped, okay, and this is going to be circle which is cut here, right? What should be the minimum value of h? This is h, okay. What should be the minimum value of h so that it completes the vertical circular motion? So as we know, if it needs to complete the vertical circular motion, the speed here should be root under 5gr. Do you agree? Yes, right? So minimum speed should be that. So of course you can complete work energy theorem. You can write work energy theorem and then you can find it. So work done by gravity, which is mgh. So h is a variable which we need to find. So work done by normal force is 0, and we know that the final thing should be root 5gr, which is whole squared, and we get 5gr. And initial kinetic energy is 0 because we have just started to drop it from rest rate. So yeah, so this is also a good type of question where you see where the particle loses contact, okay, at what angle. So basically in this type of question you have to use two formulas, which is the NLM thing and then work energy theorem. So when it drops, we know that it will be having n normal force and mg force acting downwards, and normal force will become 0 because the moment it gets out of contact of the surface, the normal force stops acting and it will be becoming 0. Fine. So let's first write the work energy theorem. So work done by normal force plus work done by gravity is equal to change in kinetic energy. Okay, so what is this? So this is basically r, then this is basically r cos theta, then this is r minus r cos theta. Okay, if you agree with me, then I can write this equation with no confusions, right? So yeah, now let me write this NLM equation, which is mg cos theta minus n will be equal to mv square by r. Do you agree? And n will be equal to 0 when it loses the contact, so mv square will be equal to, taking r on this side, mg r cos theta. Now you can see mv square in the equation 1 also, so I'm going to substitute this value on the equation 1 and I'll get something like this, and I can find the cos theta value, which is 2 by 3. If you want the theta value, it's cos inverse 2 by 3. The next question, a small block slides with velocity 0.5 g r. So g is 10 and r is basically the radius at this point. This is a good question. I think the answer is already given and you can try this as your homework. This same type of question. Basically we need to apply the work energy theorem and the NLM equation. So yeah, I think this is easy question. This is the part where they ask in JEE advanced. So whenever they drop from angle, let's say this angle is theta and this entire angle between this and this is theta 2, theta 1 and theta 2, and you can apply this equation where this will be r cos theta 1 and this will be r cos theta 2, right? So you can apply the mgh. So it comes from here to here, it goes from here to here. So mgh will be this, and then yeah, kinetic energy. I think this is not a big deal, even though it's only asking J advanced. So yeah, you can also find the tension maximum and tension minimum. Tension maximum will be at the minimum will be at the top right here. Okay, of course you can apply the formula NLM equation and get this. Just try this yourself. Okay, please try this yourself. I'm not gonna do this. Take a screenshot and please try this, because if I do this, this video will get lengthier and lengthier, so that I can't actually cover the part in short time. I just skip it because a lot of JEE main students would have been seeing this video, so that if I solve JEE advanced problems, I think it will take a lot of time. If you want, just put in the comment box. I will take a separate lecture on JEE advanced problems for sure. Fine. Next topic, and this is the last topic, which is conservative and non-conservative force. Don't be so complicated with this structure. I have made it complicated. So basically, let's take a point A to point B. Okay, I can do this in different ways, and work done by these all things are, let's say, work done by force F1, work done by F2. So I can tell that every force will be equal, and it only depends on the initial and final path in what? Conservative forces. Okay, and these forces are called conservative forces. Okay, work done is path independent. So whatever the path it can take, so it can go like this, it can go like this also and go to B. It only depends on initial and final position. Those are called conservative forces. And in conservative forces, closed loop, the work done will be 0. So let's take mg. Okay, let's take, this is at a height h. Let's say it's gonna move like this and reach the point B, right? So will you take all the path which is traveling? No, right? So basically you will take the height, this difference between the height, and then you will take the vertical displacement, right? So it basically depends on the initial and final position. So mg is an example of that, and electrostatic is also example of that. So non-conservative is a complete opposite of that, which is work done is a path dependent, and at a closed loop, work done will be non-zero. Example, friction. Friction is a great example for this, because see, more the path is, the work done by the friction will get more and more. That's basically a path dependent, right? So yeah, so how to find whether the particular force is path dependent, conservative or not? So this is a least important thing. They barely ask this, but for the sake of completion, I'm gonna complete it. But you can also remember, when you go for higher studies, it will be definitely useful. When they give a force equation like this, F is equal to Fx I cap plus Fy j cap. So basically you need to take the determinant of that and equate it to 0. So partial differentiation by dx. Okay. So fx, fy, fz. This is not important. Just look at, take a glance of it. That's it. Next thing is concept of potential energy. So basically, let's take a particle is here, and I am applying. I am throwing it in velocity v, and it reaches v final, right? So it becomes 0 at the top. And when this becomes 0, kinetic energy also becomes 0. And what can you say? Where did it go? How the kinetic energy, initially it was 100, right? And finally how it came to 0. So basically it is because the maybe the reason could be like gravity is doing negative work. Since it's doing negative work, it reduces the kinetic energy to 0, because of work energy theorem, I can say this, right? So work done by gravity is negative. That can be one reason. That is also a good reason. I mean, that's the only reason I can, what we could think about after studying this chapter. And we also observed that let's say it goes to 0, right? It is at initially at 100, it becomes 60, 40, and finally 0. And when it comes down from 0, it becomes 50, 60, and comes to 100 at last. Potential energy compensates the kinetic energy. Wherever the kinetic energy becomes less, there will be something called potential energy to compensate it. Okay, so if you don't understand that, it's perfectly fine. What you need to understand is du, which is potential energy, is equal to minus of internal conservative forces. Remember, only internal conservative forces are taken, only define for conservative forces and the system particles, not a point particles. It's a group of system. Okay, let's say for example we have question: a particle travels with velocity v, finally it gets a final velocity is equal to 0. Okay, we need to find the potential energy. Okay, du is equal to minus of work done by gravity. Gravity is an conservative force, so I can take it. I have no problem with that. So delta u is equal to minus mgh. So that becomes plus, and uf minus ui is equal to mgh. So if the initial potential is given as 0, then the final potential will be simply mgh. Okay. So what about in this question? So spring force is also dependent on the final and initial position, right? Whatever it can do, but it does depend on the final and initial position instead of the path. So in that case also, I can find the potential energy in this question also. Okay, I think this is same kind of question. And spring potential energy is equal to 1 by 2 kx square. This you can remember as a formula, or you can do according to this: delta u is equal to minus wt by spring, right? Internal conservative forces. Next thing is let's take a spring connected to a block, and we are going to drop the block, and let's say it goes with it goes down, and we can definitely say it's going to be mg is going to be acting. Okay, So the distance will be 2 mg by k. Kx is equal to gravity. I hope you understand that. And then the work done is simply the distance, right? So what's just applying this formula, potential energy of spring, and where x square will be 2 mg by k whole square. Okay, I think you understand this. Yeah. So a wedge of mass is fitted in a spring of stiffness k, is kept on a smooth horizontal surface. So basically a wedge is kept. Since a wedge is kept, I can tell a normal force will be acting in this direction for sure, and then n cos theta, n sin theta are the components. So, and here, due to the spring, kx force will be acting, right? So by the Newton's laws of motion, I can tell kx is equal to n sin theta, right? So x is equal to n sin theta by k. Okay. So this will be the compression of the spring, compression or extension of the spring. So 1 by 2 kx square will be the potential energy formula. So put this x value here and find the value. Right. Next thing is relation between F and U. Okay, force and potential. So basically, the partial differentiation of the potential will give you the force. So basically, if you want the force, you need to differentiate du by keeping dx constant. Minus should be at the front, never forget this. Okay. So yeah, and du, and by keeping, this is partial differentiation. No, I'm mentioning du. It's normal differentiation, but this is partial differentiation. Okay, I hope you understand the difference. If you don't know how to solve, uh, the next question is about that. Let's take u is equal to 3xy. We need to find the force at 2, 3. Partial differentiate this equation by keeping x constant, y constant, and then what? That's it, right? Z is not there, so there is no extra headache. So when you keep this constant, this will come outside and x will get removed when you differentiate it, and 3. So 3y I cap, right? So yeah, minus should be there. Again, minus du by dy, which gives you minus 3xj cap, right? So put in this equation, like combined equation, so this will be the value. Okay, again partial differentiation, but here we have 3 variables, so partial differentiation by keeping z, x, and y constant, you'll get the answer. Okay, so simply at the end the result speaks what did you understand. So basically when they give the equation for you, and if they ask you to find the force, you need to do a partial differentiation. That's it. So f is equal to 3x plus 4y. In this case they have given force and they are asking you to find the potential. Okay, so if potential energy at 1, 2 is given, okay, so find the potential energy of 2, 5. Okay, now just we know the formula that du is equal to minus of work done, right? So work done we have studied long before in the previous video, that fx dx plus fy dy, those are things, right? So I hope you understand just the same formula here, and yeah, integrate, just get integrated and you will get the final answer. UF minus U initial will be equal to the final answer. Fine, let us study about equilibrium. I think this is the part where we feel a little relief in this chapter. Yeah. So basically, what are equilibrium? Equilibrium is the position where any objects wanted to attain. Fine. Even in our life, we need to attain equilibrium where we don't have external pressures to do something. You know, to attain equilibrium is the only reason why we study. Okay. So yeah, I know this sounds really unimportant, but attaining equilibrium is very important. Okay, let's come back. So at this point, let's say I'm gonna push it little bit. Okay, this side. So when it goes here, you can clearly visualize that it comes back to the same position, right? So this is gonna be known as stable equilibrium. Okay. So what about in this case? This is a particle and I'm going to push in this direction. What will happen? The moment it crosses the equilibrium position, it goes like this, right? Okay. And falls away. Okay, that will be known as unstable equilibrium. So what about this? Let's take an object and push this on this side. It will be here, no problem. After that, it will attain equilibrium. Whichever moment it goes, it attains equilibrium. That's called as neutral equilibrium. Okay, so at equilibrium, for every equilibrium, this is the condition. So F will be equal to 0. Okay, which we have studied that F is equal to du by dr, right? So du by dr will be equal to 0 indirectly. Fine. If any question like they have given an potential energy equation, and if they ask you to find the equilibrium position or mean position, just differentiate it and equate it to 0. That's it. So similarly here, we have given an equation and we have said to find the mean position or the equilibrium position. So yeah, differentiate it, which is 4x minus, and this will become 1 when we differentiate it. Equate it to 0. F is equal to 0. So you will find the x value, which is the equilibrium position. So these are the results. Just remember these. Let's take only x-axis in this case. When it is stable equilibrium, du by dx is equal to 0. When it is unstable also, it's going to be the same. Neutral also, it's going to be the same. This is the universal condition for the equilibrium, irrespective of whatever equilibrium you analyze. Right? But what does differ? The difference occurs in the double differentiation. So when you double differentiate the equation of the potential energy of the stable equilibrium, it will be greater than 0. So see, stable greater than 0, unstable where you are in poverty lesser than 0, neutral equal to 0. I think it shouldn't be a much complicated process to understand. So remember this. Fine. Next thing is graph. Some questions may involve like they can give a graph and say the point or how many points are the equilibrium point they can ask. So just remember that whenever the slope is equal to 0, because du by dx is equal to 0, in the potential energy versus x graph, so that will basically represent the what, equilibrium position. Okay, so yeah, in this case this will be the equilibrium position. Let's take this as x naught. So what about this? So according to the definition, we know that F is equal to minus du by dx and minus slope, which means at this point the slope is positive, then force will be negative. At this point, slope will be negative and force will be positive, and this will be the equilibrium point, which means a particle, when it goes here, it pushes back here. When it goes here, it pushes back here. Always the particle will try to reach the point, x0 point. Okay. So yeah, mark the equilibrium positions in the graph. Of course, here slope is 0, slope is 0, slope is 0, slope is 0, slope is 0. These are the equilibrium positions. But how will you find whether it's stable equilibrium or unstable equilibrium? So basically, when you become stable in the life, you will laugh, you will smile, you smile, stable equilibrium. Whenever you become unstable in the life, you become sad. Yeah. Whenever you become neutral, this is how your reaction will be. I hope you understood. So yeah, going further, I think we have approached the end of the chapter. So u will be equal to x square minus 2x. Find the equilibrium position and its type. Okay. So basically, to find the equilibrium position, I've always said to differentiate it and equate it to 0. So of course you can do that, and you can get the x value is equal to 1. Okay. How to find the type of equilibrium? So basically double differentiate it and check the value of that, and it comes to which is greater than 0. Whenever it's greater than 0, I have told it's definitely a stable equilibrium condition. The last but not the least, no, last but the least thing is mechanical energy conservation, which is kinetic energy plus potential energy will be equal to mechanical energy. Okay. So basically what this mechanical energy conservation says is kinetic energy initial plus potential energy initial will be equal to kinetic energy final plus potential energy final. This is the law. And yeah, we are completing this chapter with this. So guys, please revise the things, and this is the time to say sorry. Spelling mistake could cause my video end late. So thank you for watching this. Please subscribe. I think please subscribe to support me. I have nothing to say. Thank you.